Okay, so in this section, we're just really dealing with a bunch of formulas. And that's mathematically, that's kind of boring. It's not too bad, as I'm guessing from a student side, because you just have to be able to punch the stuff in your calculator the right way, so it's not like anything like really hard. Okay. But remember, we're trying to kind of keep the big picture in mind, okay, on this stuff. So pretty much everybody has to deal with money, at least some. And so it's a good idea to have at least a basic understanding, okay, what's going on when we're trying to take a loan or things like that, okay? Or investing, right? You can think of it the other way around too. So that's really the big picture goal here. Okay? We have a few types of calculations we're going to look at in this section. We're going to start with simple interest, and then we're going to look at future value and compound interest. These are really they go together. Okay? And then the last calculation we're going to look at is annual percentage yield. Okay. A few of those. We got a quote that our textbook authors are saying is attributed to Albert Einstein. I'm not sure. That pretty smart guy. Said the most powerful force in the universe is compound interest. So why would he say something like that? Well, the world runs on compound interest. Okay? It's the way businesses make money. That's why people are willing to give you a loan, so you'll pay interest, kind of thing. So interest is important. Okay, it affects multiple parts of our lives, and especially compound interest. So we want to have at least a basic understanding of what's going on, some different things that can affect our money. That's our goal for the rest of this class. Okay. So let's start with some terminology. I have some vocabulary terms here. I got interest, it's our first one, and right now we're thinking about it from the perspective of borrowing money. So our definition says it's the amount charged by a lender for borrowing money. You can think about it the other way around. You can think about if you're investing money, it's the amount you earn from your investment. Hopefully. Think about it either way around. And number two here, this one will be important for us in just a moment, is principal. So principal is the part that's not the interest. Okay? You can think about the principal like the starting amount. So you can think about that's the initial amount you take out a loan for, or you can think about that's the amount you start an investment with, our principal. And it's the principal spelling, P-A-L on the end. I'm not going to count off for spelling or anything. I'm just making a note of it. All right. All right. Did I caught you? Huh? Caught you. Yeah. No, I tend to try to put LE on that one too. All right, and then one that's going to be really important, and that we see a lot if you look for it, is interest rate. The idea of the interest rate is that we are expressing the interest as a percentage of principal. The percentage we'll just say a percentage number. We're treating it as a percentage of the principal we're working with. If you have a percentage, it has to be a percentage of something. So 4% of 100,000 is not the same as 4% of a million, but we can talk about the interest rate being 4% on both of those. Okay. And then the way we're going to be talking about the interest rate most of the time is as an annual percentage rate. And shorten that to APR. If you look for that term, you will see it everywhere. Okay. And that's the idea of taking our interest rate and spreading it out over a year. So normally when you see APR or annual percentage rate, you'll see it given as some percent per year. So 6% per year, something like that. So holiday season's coming up. If you see commercials, you'll have car advertisements. They'll say you get a low rate of 0.6% APR financing, blah, 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 blah. Right? That's one place that comes up. You want to buy something on credit. Student loans, you probably don't pay attention to APR on those, but there. Can't really do much about it on those. It's also there. APR is also involved if we're opening a savings account or making some type of investment. It's everywhere. Okay, so there's our vocab. Let's look at our first formula. Okay. So the first number we want to be able to calculate is called simple interest. Okay. The formula for it is not bad at all. Okay. But we do, in these next few sections, we do want to make sure we know what each one of the symbols stands for in the formula. That's a big part of being able to come up with the correct answer on these. Okay. So our formula, that's an I, it just doesn't have serif. I equals PRT is our formula. So I, we're calculating interest, so that's I. And we're going to take our principal, our starting amount, P, multiply that by R, which is our annual interest rate. And we've got a note there, okay, that's important. R we want written in decimal form. So it's given to us as a percentage, but when we use it in our formula, we need to change it to a decimal. Okay, and then T is our time or the term of the loan or whatever we're calculating, and it's in years. That's how we want T usually. All right. The math part of it's easy. We just multiply everything together. Okay. So no big deal on the math part. As long as we get the right numbers in the right form, we're in good shape on it. All right, so let's look at one. It says determine the interest that is accrued, just how much interest we earn on $5,500 for 5 years at a rate of 8.5%. Okay, so our formula, I equals PRT. Okay, so our starting amount, our principal, is $5,500. And it says we're going to leave it in there for 5 years. So T will be 5 years. And then for our interest rate, we've got to change it to a decimal. So if we change 8.5 to a decimal, that would be 0.085. Now we move our decimal place 2 places to the left. And so started off between the 8 and the 5, we move it in front of the 8, and then when we move it the second time, we have to add a 0. Okay. And we just multiply. So 5,500 times 0.085 times 5 years. We'll get our interest. Let's see what we get there. So that investment would earn $2,337.50. Your calculator will probably give it to you as 0.5. It's money, so we can call it 50 cents. Okay. The calculation's not bad. We just have to make sure we have our R in decimal form, and we make sure that T is in years. This one gave it T to us in years, so it's not bad. One other thing to take note of here is this formula we have, I equals PRT, just gives us the interest earned. It doesn't tell us how much money total we'll end up with. If we want to know the total amount of money that we would end up with, we have to take our interest and then add it back to our starting amount. So we would do the $23,3750 plus $5,500 if we wanted to know how much money we end up with in total. So you can have some problems ask you either one. Questions on that one? It's not bad. Okay, look at another one. This one says, Ian's purchasing a new television with a deal from Big Screens R Us. The deal offers 90 days, same as cash, to make the purchase. Okay. What that means is that if he pays off the whole cost of the television within the 90 days, he doesn't have to pay interest. Okay. But if he doesn't pay the amount off completely, he owes simple interest for the original purchase amount calculated over the entire 90 days. So either he pays it off and pays no interest, or he pays interest on the whole thing. Okay. The price of the television is $2,650 with tax included, with an annual interest rate of 21.99%. How much would Ian owe on the 91st day if he made no payments during the first 90 days? So we're just trying to figure out the total cost he would have for the television. Okay. So we can figure out the interest that he would have to pay, and then just to add that back to our original price, we'll get the total in this one. Okay. So let's see, here's our formula again. I'll put it up top. So we need P, R, and T. Okay. The P, our principal, is our starting amount, so that's just the original price of the television. P. And it gives us our annual interest rate is 21.99%. That's going to give us R, but we've got to change it to a decimal. So we move our decimal place 2 places to the left. That'll be 0.2199. And then we have just a little bit of a curve on this one because the time that he would be paying interest for is not given to us in years. The times we're given is 90 days. Okay. So you could change that to years, right, by taking 90 days out of 365 days in the year and get a decimal that way. Our textbook takes kind of estimates just a little bit. There's really not much difference in the way they do it, but what they're doing is they're calling 90 days 3 months. Okay, which sometimes it would be, sometimes it's not. But so if we call 90 days 3 months, then we'd be paying interest for 3 out of 12 months, 12 months in a year, and that's 0.25. if you did it the other way, okay, if you did 90 out of 365, that's like 0.25, I don't know, 0.246 something. So it rounds. If you round the two places, it rounds the same anyway. It's really close, but unfortunately, you will learn if you owe somebody money, they're not going to say close enough's good enough. Okay? They're gonna, there's a decimal point that they can move to get some more money out of you. They will. Okay, so, but we'll call that good enough. Okay. So to figure out our interest, the price of the television, which is $26.50, times our interest rate, which was 0.2199, times T, which we have is 0.25 years. Okay. So this will give us the interest he would owe. Okay. $26.50 times 0.2199 times 0.25. There, if we round to the nearest cent, that would be $145.68. That's not what the problem asked for. It asked us for the total that he would owe. So to get the total, we take our starting price and add the interest back to it. So total price would be $2,795.68. Questions there? Okay, so math's not that exciting. Let's think about the life application here. Okay? Because these deals are out there. Okay? You have these same as cash offers. Let's think about pros and cons there. Okay? So if you pay it off within 90 days, you don't have to pay any interest, so that's great. You don't pay any extra. But if you're so confident you can pay the whole amount in 90 days, why don't you just save money for 90 days and then go buy it and not have any risk of having to pay interest? Okay, so something to think about there. If the situation really calls for you need to have it now, and you can't pay for the whole thing now, you have to decide, is it worth it that if I don't get this thing paid off, I'm going to pay basically an extra $150 for it if I have to pay interest. I typically don't like paying an extra $150 when I want to buy something. So you just have to decide if that risk is worth it. Usually when you have deals like this, the 90 days same as cash, it's not on items that would be an emergency. Right? Usually it's something you can wait for a month or two on and then buy it then. One other thing to think about on these, just trying to make you wise. Okay. If you have a company offering a deal like this, where you can have 90 days same as cash, if somebody buys it on that deal and pays it off within the 90 days, does it benefit the company any? Store that's doing that deal? Do they make anything extra? No. So why do you think they would go to the trouble of putting that offer out there? Not everybody's going to pay it off in 90 days. In fact, probably a significant percentage of people are not going to pay it off. So what happens then they make an extra $145.68. Okay. So if everybody just paid it off, they wouldn't bother. Okay. So just think about that. Okay. All right, let's see, what's next? Let's do one more where T is not in years. Just where we have to do one more conversion. This one says, find the total cost of a loan for $4,320 that has a simple interest rate of 15% for 18 months. Here our starting number P, 4320. We're given our interest rate, but we need to take it and change it to a decimal, so 0.15. And then for T, we need to take our 18 months, change that to years. So we can do that. We can take 18 and divide that by 12 months in a year. Or you may just be able to see that's a year and a half. That's okay. We get 1.5. We divide it by 12 because 12 months in a year. So our interest would be 4320 times 0.15 times 1.5. So what's that going to cost us? It would be $972 of interest. So to get the total cost, take our 4320, add the $972, and we get $52.92. So something you need to think about when you're taking a loan. Okay, all that's happening when you take a loan is you're paying extra to use money now instead of later. Okay? So what we're going to end up doing, we're going to end up paying almost $5,300 now instead of $4,320 18 months from now. We've got an 18-month loan. So how you can think of it, right, is in order to get this $4,320 18 months sooner, and we're going to end up paying about $5,300. Cost us almost $1,000. Okay. Questions there? You are quiet. Not even sniffing a lot or anything today. Crickets in here. All right, we'll go on. Okay. So simple interest does come up some places. You can take some simple interest loans. If you're taking a loan for a smaller amount of money, sometimes you can get a simple interest loan. But most of the time, if we're borrowing or investing, what we're dealing with is a different type of interest called compound interest. Okay. The idea of compound interest is that we have some certain interval, some time period, where every time that time period passes, we're going to calculate the interest. And then when we do that, we add that interest back to the principal. Okay. So what happens is that if nothing changes, right, we're not making payments or anything like that if we're thinking of a loan, then every time that interest compounds, the amount that we owe gets bigger and bigger and bigger. Right? Because every time we compound, we're compounding on a bigger number. Right? We're calculating interest on a bigger number than we did last time because we're adding that interest back in every time. For a loan, that's not great. Okay? That means to pay off a loan, we have to make payments faster to make it go down faster than it's growing. Okay, so that can feel like fighting a losing battle. Okay? If we're investing, that's good. And that means we invest and it just grows and grows and grows and grows and grows. So compound interest is really powerful, like we saw in that quote. Our formula for compound interest is going to start with A. It's going to say A equals, so A is just like the total amount of money. Okay. We've already seen some of these, so R still our percentage rate, annual percentage rate. Okay. P still our principal or starting amount. T still in years. So we have one new variable that's introduced, and that what we call N. That is our compounding interval. That's how often we are calculating the interest and adding that back in. So we can do that for different time periods. You can pick any time period you want. Okay? So if we wanted to do something weird, like if we wanted to give somebody a loan and we wanted to compound the interest every 17 days or something weird, we could. Okay? Normally we have certain intervals that are really common that get used a lot. So in the problems, it's not normally going to give us N as a number. It's going to give it to us as words, and we have to know what number goes with that. So here are some common ones. Okay. We'll come back. Here are some common ones for N. Okay. So if we say our interest is compounded annually, that means once per year, so N would be 1. Okay. We have semi-annually, is twice a year. Quarterly, we have 4 quarters in a whole. Right, so quarterly means 4. We have 12 months in a year, so monthly would mean N would be 12. 52 weeks in a year. So if we're compounding weekly, N would be 52. Or here we're using for daily, we're saying we have 365 days in a year. So N would be compounded 365 times. If you owe somebody money and they say it's compounded daily, they're not going to use 365. Because what about leap year? So what they're going to do is they're going to use 365.25. That way every 4 years they get an extra day in there. Makes them a few more dollars. I mean, we're just going to use 365. All right, so and then here's our formula. Okay? Remember, A is just the total amount of money we have. So a little different than the simple interest formula. The simple interest formula just gave us the interest. This formula we're using for compound interest gives us the total, so the principal plus the interest. That's what we get here. Okay. So it's just our starting amount times 1 plus our interest rate as a decimal divided by whatever N is. That's how many times a year we're compounding. And then we have an exponent that is N times T, the number of years. So as long as we get all the numbers in the right place, it's not a hard formula, but it can be a little aggravating to type in your calculator. That's why one reason why I said a scientific calculator is going to be helpful. It's just easier to do parentheses and exponents in one than it is in just a little 4-function calculator. So scientific is going to be really helpful. And I think mine's about dead. I hear something rattling around in there. So I had it several years. So. Okay. So let's look at one of these. Again, I'll give you all the formulas. Okay, so you just need to know how to use them. Okay. I will confess I do not have all the financial formulas memorized that we will use. This one I know, but not some in the other sections. Okay. So let's see. Okay. Since it says Lily deposits $12,000 into an account with an annual interest rate of 4.5% compounded monthly. So it tells us it's compound interest. If she leaves the money in the account for 10 years, what will the future value be at the end of this time period? Okay. So let's pick out our numbers. Our starting amount, our principal P, $12,000. Our annual interest rate, 4.5%. Remember, we have to change that to a decimal, so R will be 0.045. Our time in years is T. It's already in years, so we don't have to worry about that. But then remember, we have that one other new number we have to worry about N, how often we're compounding. So this one says it's compounded monthly, so what number should we use for N? How many months in a year? 12. That'll be N. Okay, so plugging into our formula, that is 12,000 for P times 1 plus R, which is 0.045, over N, which is 12. And then in our exponent, we have 12 times T, which is 10. You can punch this in your calculator all at once. Sometimes I do, sometimes I don't. Lots of times I will do the inside part here, raise it to the exponent, and then do times 12,000. That works too. You want to make sure, okay, if you don't have it with you today, you want to make sure you can punch these examples into your calculator and get the right number out. Okay? Sometimes if you get one parenthesis in the wrong place, it throws the whole thing off. Okay? So the way I'm going to punch mine, I'm going to do parenthesis 1 plus 0.045 divided by 12, close my parentheses, and raise that to an exponent. I'm going to go ahead and do the 12 times 10 part, so I'm going to raise my exponent to 120. You can do 12 times 10 in the exponent on most calculators, so not that big a deal. And then once I get that answer, I'm going to multiply it by the 12,000. Here, I get $18,803, and that rounds to 91 cents. Okay. If you just wanted the interest, yeah, you could subtract the 12,000. This one asks us for, what did it ask for? What's the future value going to be? So it's like the total on this one. Yeah, yeah, but that's a good point. If it just asks for the interest, you do is take this number and subtract the principal. So if we did that on this one, we could, if we said how much interest would we earn, we get $6,803.91. That's just a side note for this particular problem, though. Other questions on that one? Nothing? Okay. Okay, let's look at this then. All we're going to change, okay, we're going to use all the same information from the last problem, except instead of 10 years, we're going to leave our money in that account for 20 years, or in that investment for 20 years. So all we're changing, we're going to just change T to 20. Okay. Let's see how much difference it makes. Okay, so still starting with $12,000. Interest rate still 4.5%. Still compounding monthly. This time we are leaving it in there for 20 years. So we're leaving it in the account for twice as long. What do you think is going to happen? You think we're going to end up with twice as much money? we end up with $29,465, and that rounds to 60 cents. If we wanted to figure out how much interest, oops, sorry. If we wanted to figure out how much interest that earned, we could subtract the 12,000. So in 20 years, we earn $17,465.60 in interest. Haven't done anything except left it in there long. So for the 10 years, what was our interest? 6803.91. But for 20 years, earn this much interest. So it's way more than double. Right? Left it in there for twice as long, but the interest we've earned is way more than double. Okay? That happens because every time interest is compounded, every time it's calculated, we take that interest and add it back into our number, add it back into our principal. Then the next time when we compound interest, it's calculated on a bigger number, so we have more interest than we had the last time. And we'll have more the next time, and more the next time, and more the next time. So it grows faster and faster. So this T, okay, remember we didn't change the interest rate, didn't change how much we paid in. Okay. All we've done is we've changed how long we left it sitting there. So this T, out of the things we can control if we're trying to invest money, T, how long we leave it sitting there, is a major factor. Major factor. So the interest rate's going to be what it's going to be, and compounding interval is going to be what it's going to be. The things we have major control over are the starting amount. That's assuming we have more. We could put more in there, or the T. By far, T has a bigger effect, and then proportionately than changing our starting amount. Okay. So I'm saying all that. I know a bunch of youngsters in here. You're probably not thinking about trying to get ready for retirement or anything, but try not to roll your eyes if you hear someone tell you you need to start planning for retirement early. Okay. Because the earlier you can start, okay, that has a disproportionately large effect on how much you end up with. So the earlier you start, the better. It doesn't have to be right now. You're not there yet. Okay. Most of you, but you want to start as early as you can. Okay. So let me do one more. Okay. So I'm going to do one more, except I'm going to go to 40 years. So start working at 24, retire at 64. So let's think about that. So that'd be 1 plus 0.045, and this is not even a great interest rate for a long-term investment. Okay, divided by 12 to the 12 times 40. And so here at 40 years, this would be $72,351.78. So it grows faster and faster the longer you leave it in there. So double the time again, and again, we ended up with a good bit more than double the money. Did not change how much we invested. So time's your friend on stuff like that. All right, enough of that. Let's see. Okay, so one other thing to mention here. it's less common, but let's go back to our n. Okay? So n does affect how much we end up with. Okay? The bigger n is, then the more we're going to end up with after the same time, right? So like if we're making an investment for 10 years and it's compounded quarterly versus it's compounded daily, the one that's compounded daily, we're going to end up with more money, okay, because we're compounding more often. Okay? So that does have an effect. If you look at our formula, it's not quite as big of an effect as t. You would think it would be because it's there in the exponent also, but it's kind of mitigated by the fact that we're dividing our interest rate by n here. Okay, but it does increase how much we end up with. And the thought on that is, well, if compounding more often is better, like if I just increase the number of times I'm compounding and it makes me get more money, maybe I could compound every second or something like that, right? That would be a big number to compound by. Would that mean I had infinite money? No, that would be nice. I know there's a limit to it. Okay, there's a limit to it. So the bigger the n, the better. Okay? But there's a certain number that it approaches, and as it gets closer to approaching that number, the slower it starts increasing, right? So it slows down and slows down and slows down. It gets bigger, but it just slows down how much bigger it gets. Right? And that limit that we approach, okay, we give that number a name. Okay? It pops up everywhere. Okay? If we use that as our compounding interval, what we say, that limit, we call that continuously compounded interest. So it's like we're just every instant we're going to compound. Okay? So we have a formula for continuously compounded interest. And that number, that limit that we approach when we increase our compounding intervals is the number e. So e is just a number here. It's a constant value, like pi. So pi, if we estimate it, we call pi about 3.14. Okay. Anybody familiar with e, know about what e is equal to approximately? Anybody? The e is about, anybody know the first digit? It's 2, so it's about 2.72 if we go 2 decimal places. Okay. It's an irrational number like pi. E has decimal places and it goes forever and ever and never repeats. But there's a button on your calculator for e. If you need help finding it, see me. I'll help you find it on there. Okay. But if we want to think about continuously compounding something, then we use this formula. Okay. That's p times e to the RT. That's like the maximum compounding we can do. Okay. That's it. You do that, and then for the x part, you would do the whatever RT is. Yeah. Okay. That's there. Okay. So let's use this formula. Okay. So you know you're going to use this formula for compound interest if you see the keyword continuously. Okay. So this is continuously compounded interest. If you see any other compounding word, then that's going to be, we have to figure out what n should be. This one we are starting with principal of $8,900. Our interest rate is 2.05, so R be 0.0205, and then T would be 15. So here, if we're continuously compounding, it would be 8,900 times E to the 0.0205 times 15 power. Okay. So we need to know where the D button's at, right? So I'm going to do E to the 0.0205 times 15 power times 8,900. So this would give us $12,104 and rounds to 19 cents. So once you find the E button, it's not hard. And you know to use the one with E in there if it says compounded continuously. E is a very interesting number because it pops up, like it just pops up here in financial math. It pops up in all kinds of different situations. I call it E. It's named after a person, and then their last name starts with E. So. All right. Let's do one more with this formula. This is another way it can be worded. Says we're going to deposit $2,500 into an account at 6% interest for 10 years. A says what's the maximum future value possible? And so it's just asking what the maximum total is that we could get. So if you see something like that where it's asking for the maximum, it's talking about if we compound continuously. Okay? Because we're going to leave the P, R, and T fixed. And we're just talking about changing N. So here we would take our $2,500, multiply that by E to the R would be 0.06, 6%, and then 10 years, so E would be 10. So let's see what we get there. And so there, we get $4,555.30 when we round. Okay. And then B says what's the maximum amount of interest. So we just want to know how much interest we had on part A. So to get that, we just take our total amount and subtract our principal, or starting amount, to figure out how much interest we earned. So there, $2,055.30 of that would be interest. Hang in there, we're getting there. I know most of the business and finance people are not in here, so that's not really what most of you are into. Almost done, almost done. Okay. We got one more type of calculation we want to do. And that's called the annual percentage yield. It looks messy, it's not that bad though. Annual percentage yield, or APY. So APR is supposed to give us our annual percentage rate of interest. But when we're dealing with compound interest, if we're compounding more than once a year, and we actually end up with more interest than the APR suggests. Okay? So APR is accurate if we're only compounding once a year. But if we're compounding more than once a year, when we compound on the old interest, it throws our actual interest off a little bit, and it doesn't match the APR. Okay? So APY gives us the actual percentage that we can expect to earn or expect to pay in interest for a given rate and a given compounding interval. So our wallets care about APY. They don't care about APR. because what you actually end up paying or earning is APY, not APR. So I have seen some car commercials lately where they're, instead of giving APR on there for their finance rates, they give APY. So that's a little bit more honest. That's nice to see. Okay. So the formula is not bad. Okay. I don't even think about this times 100% part when I'm doing it. So then all we need is this part. And this is like the parenthesis part of the compound interest, but without the T. And then we just subtract 1. Okay. So still R rate is a decimal, in how many times a year we're compounding. So it's not that bad. And then we just have to remember to change it to a percentage at the end. That's what the times 100% is doing there. Let's look at one. So two-parter, and then we'll be done with that one. Okay. It says Samantha deposits $5,000 into an account paying 5% interest per year, 5% APR. Okay. We want to find the APY for Samantha's investment. On the first part, if the interest is compounded monthly. Okay. So P 5,000 R going to be 0.05. Okay. We don't care about time with APY. Okay. So, because we end up with annual percentage yield. Okay. So then using our formula, I'm going to go to the next slide so we have a little more room here. Here's our formula again. It's 1 plus R over N to the N minus 1, and then we change it to a percentage at the end. So you can write the times 1. So we would have 1 plus, our R was 0.05. Oh, well, I left out a number. Right. What about N? What's N going to be on A part? It is compounded monthly, so N is going to be 12. That's right. Okay. N is going to be 12. Yeah, I didn't mention it, but we also don't care about T here. What else do we not care about? I don't care about P if you look at the formula. We just need R and N. So N is going to be 12. So let's do that part. So 1 plus 0.05 divided by 12, and raise that to the 12th power. Okay. And if we subtract 1, we end up with our decimal. I'm going to keep several decimal places here. And then we want to change it to a percentage, so you can either do times 100 or you can move the decimal place 2 places. So our APY on part A would be I'm going to do 5.12%. So the annual percentage rate is 5%, but because it's compounded several times in a year, the actual effective interest she'll earn is 5.12%. So you might not think you care about that 0.12%, but the fractions of a percent of interest is what makes the world go around. Okay? If you're think about it, if you're going to lose out on 0.12% of $1 trillion, that's a lot of money. So that 0.12% is important. That can be the difference in a business being profitable and closing down. So, and then B part, all we're doing is we're changing our compounding interval. So here it says we're going to compound daily. So what's N going to be for daily compounding? 365. 365. So on B part, I will have 1 plus, same numbers for R. This time N is 365 We'll raise that to the 365th power. Track 1. There I get 0.051267 something. And then either multiply by 100 or move the decimal place 2 places, because we want it to be a percentage. There, I'd call that 5.13%. APY. So on both of those, APR is 5%, but we get different effective interest and because of the compounding that's going on. Questions on that one? All right, one more problem for us to look at. We'll go through it quick. Okay. One more for us to look at because this one's actually kind of interesting. Okay. Let's look at this one. So, can't wait on your paycheck. You go to a payday loan place, take out a loan on your upcoming paycheck. Okay. You get in this kind of situation. It says, assume you wish to borrow $300 for 2 weeks in the form of a payday loan, and the amount of interest you must pay is $25 per $100 we borrow. That means at the end of 2 weeks, we're going to owe $375. Okay. I want to know what the APR is for that. Okay. So per $100, we've got to pay $25. So 25 out of 100, that is 25%. That is not our APR. I remember APR is over a year. Okay. So let's figure out how much interest that is per week. Okay. So how many weeks are we taking our loan? 2 weeks. So let's divide that by 2. I shouldn't do it like that. Let's say this. Okay. So 25 divided by 2, that's 12.5% interest per week. But how many weeks are in a year? 52. So to figure out APR, we got to multiply by 52. So guess what APR we're paying? $650% interest. 650% interest. So not a very good interest rate there. Okay. I say that to say if there's any way around it, don't take out a payday loan. Okay? Don't take out a payday loan. So every year they try to get laws and stuff passed to limit payday loan places. You might not pay attention to it, but if you start looking around, you'll see payday loan stores everywhere. Okay? I mean, they're just every block you go. There's more payday loan places than Dollar Generals. Okay? That's why. Yeah, that's why. Okay? Because they're killing people. Killing people. All right. That's it. Yeah, that's all. 9.2. I will, if you didn't get on the sign-in sheet, make sure you get on there. And I will see you next week.
Hey, I'm having a lot of problems with like 8.1, 8.2, and 8.3. Like I've taken 8.1 4 times and I can't do it.
Okay, well, A1's a little tricky because of how they word stuff. So.
Yeah. Do you think I could come during your office hours?
Yeah, for
Maybe
sure.
Friday? Do you have office hours on Friday?
I don't have them on Friday, but if you want to come Friday after 12:15, we can.
Okay.
Just send me an email so I remember, and we'll set up the appointment.
Okay.
Sound good?
Yeah.
All right. See you then.